Alright guys, here are your notes for Unit 4, Section 2. It's called Similarity. And you don't have to write this whole thing down. We're just going to get straight to it here. I'll read it to you. This is when you use an overhead projector to enlarge an image. The image on the screen and the image on the transparency are similar. So basically even when I use my projector in class, when I use my Promethean board, these images get projected up onto the Promethean board. They're the same shape, they're just bigger on the slide so you guys can see them better. That's what a transparency does. It takes a small image on a small transparency paper and makes it really big up on the screen. The scale factor, or the ratio, is a 2-inch to 15-inch ratio or scale factor. So it's making it bigger. So similarity, let me put up here really quick a little definition for you on similarity. It's the same shape but a different size. Or actually, we should put proportional size. Could actually be the same size because a 1-to-1 ratio is still a ratio. But usually it's not the same size, so we would put proportional size. Now when you use an overhead projector to enlarge it, that's the scale factor that we're going to do right here. So let's use that scale factor. Let's put a 2/15 scale factor. So it's a 2/15 scale factor. So that's a 2-inch to 15-inch. So you can put your little inch marks there if you want to. 2 inches over 15 inches. And that's going to equal, and what we want to find out is if the perimeter of the image on the transparency is 36 inches. That's our top number. Transparency is our top number. So if 36 inches is on top, they want to know what's going to be on the bottom. How big would it actually be on the screen, which is going to be a lot bigger than 36 because it's a 2/15 scale factor right now. So what we're going to do is we're going to cross multiply. So we would get 2x equals 540, which is 36 times 15. So you get 2x equals 540, and when you divide by 2, you get x is 270. So that's 270 inches. You probably wouldn't say that something is 270 inches. You would probably want to change that to feet. So you probably want to divide it by 12. So 270 divided by 12, you get, wait, hold on. So you divide it by 12, you get 22.5. So 22.5 feet approximately. So that's what the perimeter of the image on the screen would be. Of course, that would be huge. So we would have to have one of those really big theater screens or something for that. So here's what similar polygons are. Polygons are similar if and only if, here's our biconditional statement, if and only if the angles are congruent and the sides are proportional. Angles have to be the same and the sides have to be in the same ratios. So they have to have the same ratios. They have to reduce to the same ratios. This little squiggly line is the symbol for similar. So if these two triangles are similar, that means that this angle equals this angle. This angle up top equals this angle up top. And this angle on the right would equal this angle on the right. If all three angles are equal in a triangle, then the triangles have to be similar. They have to be the same shape. If the angles are the same, then the shape is the same. So that's how we know if they're similar. If they're the same shape, and if they are the same shape, then their sides are going to be proportional to each other. So which of these figures are similar? Are these similar? Let's take a look at it. Are the angles the same? That would be yes. Are the sides in the same ratio? Well, what's my smallest side is 2. What's my smallest side to 4? 2 over 4. Would that be in the same ratio as 3 over 6? And would that be in the same ratio as 4 over 8? That's definitely, all of them are going to reduce to 1/2. So that would be yes, definitely similar. They are the same angles and they all reduce to the same ratio. This one, they all have a 1/2 ratio, 1 to 2, and the other ones are a 3 to 6. So they all reduce to a 1/2 ratio. Problem is, angles are different. So that's definitely a no, not similar. Cannot be similar if they're not the same shape. These are definitely not the same shape. This one, you've got this piece equaling this piece, so it's got to be isosceles. That means it's got to have equal angles down here as well. So you've got these two angles are equal, and you've got these two angles are equal. Definitely, yes, it's similar. They have the same angles, and they will have proportional sides. They're all going to be a 1-to-1 ratio on sides. It's going to be like a 5 to 5, 4 to 4, 2 to 2, whatever it is. It will reduce to a 1-to-1 ratio. Take a look at this little problem down here. It says find the perimeter of the above triangles. So my small triangle has 2 plus 3 plus 4. 2 plus 3 plus 4, which is 9. The big triangle has 4 plus 6 plus 8. 4 plus 6 plus 8, which is 18. What is 9 over 18 going to reduce to? And if you said 1/2, then you're correct. Reduces to 1/2. What did you notice about all the sides? What did they all reduce to? They all reduce to 1/2. So we could basically say that the perimeter, if two polygons are similar, which we already found out they were, then the ratio of their perimeters has to equal the ratio of their sides. Their perimeter ratio is going to equal the same as the side ratio. Those are going to be always equal when you have similar figures. Okay, we talked about scale factor on our notes today, so you don't need to rewrite that. Scale factor is the reduced ratio, so Jacob is making a model of the White House. The perimeter of the White House is 506 feet. Jacob will be using a scale factor of 5 feet to 1 inch. So 5 feet over 1 inch. And he's got 506 feet for the White House. We want to know how many inches that would be on his model. How many inches on his model would that be? So we would, again, cross multiply 5x equals 506. Divide by 5. He is going to get x equals 101.2 inches. Now again, you probably wouldn't say 101.2 inches. So you would divide that by 12, and you'd get about 8.4 inches, or feet, I mean about 8.4 feet. So 101.2 inches is about 8.4 feet. Number 3 is asking us to find the scale factor. That means we're assuming that these two are similar triangles. So if they're similar triangles, I got to find the pieces that match up. This matches up with this one. They're both the biggest number. So a 5 would match up to a 10. Now I could also put 10 over 5. It doesn't matter. You could put big one over small one, or small one over big one. It doesn't matter. You got to stay consistent though. So if I use the small one over the big one, then I need to put 3, which is the smallest, over 6, which is the smallest. 3 over 6. And I need to put 4, which is the medium, over 8, which is the medium. All of those are going to reduce to the same ratio. They're all going to reduce to 1/2. So that has to be, those have to be similar. The scale factor is 1/2. It's a 1 to 2 scale factor. If you had used the big one over the small one, then you would have put 6 over 3 and 8 over 4, and it would be a 2 to 1 scale factor. Both are reduced and both are right. You could use either one. Now it might specify in the problem, use small to big, then you'd use 1 to 2. It might say use big one to small one, then you'd use 2 to 1. So we'll specify it for you. Alright, let's go to the last part here. It says, what's the difference between congruence and similarity? Well, here it is. Congruent figures are the same shape and size. One would fit directly on top of the other. That's what congruent is. Similar figures are the same shape but proportional sides. Basically what that means is that they have the same angles but proportional sides. So that's what proportional sizes means, is that the angles are exactly the same. In every similar figure, your angles are going to be the same, but the sides are going to be proportional. Can two geometric figures be congruent but not similar? The answer is no. No. If they're congruent, then it will be a 1-to-1 ratio. If they're congruent, it's going to be a 1-to-1 ratio. Can two geometric figures be similar and not congruent? And that would be yes. They will be the same shape, but not necessarily the same size. One could be big, one could be small. That means they're not congruent, but they would be similar if they're proportional. Similar figures have the same shape, which means they have congruent angles, but are not necessarily the same size. They need to have proportional sides. Must have sides that are proportional. Must. And we do have one little postulate that we want to learn, which is called the AA postulate. And it basically says this. If two angles in one triangle are congruent to two angles in the other, the triangles have to be similar. You have no other choice. They have to be similar triangles if you've got two angles. You don't even need to look at the third angles. Because if two angles in one are congruent to two angles in another, then the third ones have to be congruent because they all have to add up to 180. So you just need to see if two angles in one can be found to be congruent to two angles in another. Now in this first little diagram, the first thing I notice is I notice vertical angles. So I know I have this congruent to this. The second thing I notice is parallel lines. Now when lines are parallel, that gives us alternating interior angles. So already you could say yes, it's the AA postulate because you've got two angles here and two angles there that are congruent. So you already found two angles. And the third ones would also be congruent because they're alternate interior as well. So that would definitely be yes. This one they give you a 135 and another 135. So you know those two are congruent. But they don't give you any other angles. So you can't say that these are similar. You can't tell. The reason you can't tell is because you need at least two angles, and there they only gave you one. So you can't tell there. The last one, if this piece equals this piece, then this angle must equal this angle. That's the isosceles triangle theorem. And we know we have right angles. So you've already got two angles. Again, that's yes. You have the AA postulate. So those are similar triangles. The last slide here I'm not going to do today in class, or I'll do tomorrow in class with you. You can kind of check it out. It's just how to draw a triangle that's similar to this one. We want to construct a triangle that's similar, that has a scale factor of 3. So we'll do that tomorrow in class. And I do have a Mad Gab and a puzzle. You do not need to be the first one to show me. You just need to have it written down on your paper correctly, and I will call a random student, and if it's right, you get the candy. So here it is. Here's your Mad Gab. Haste, robber, reap, I, And there's your puzzle. Write down the 2 answers that you think those are and bring them to class tomorrow. And we'll see you guys tomorrow. See ya. Bye.